Introduction: the peaceful Ediacaran world. Approximately 600 million years ago, during the Ediacaran period, Earth was a remarkably tranquil place. The land remained barren, while the oceans teemed with a rich, gooey mat of bacteria and other microbes coating the seafloor. This microbial mat was occasionally interrupted by some of the earliest known animals, simple, predominantly soft-bodied, and often immobile creatures that never ventured beyond their nutrient-rich habitat. In this primordial world, creatures seemed to coexist peacefully, deriving all necessary nutrients from the water or the microbial mat beneath them. Notably absent were large, active predators, leading scientists to describe this era as an evolutionary Shangri-La, a reference to a fictional idyllic paradise. However, this serene existence was about to undergo a dramatic transformation as some animals began to consume others, forever altering the course of evolution. The emergence of predation. While the concept of predation, obtaining nutrients and energy by killing other living things, is ancient, predation among complex animals is a more recent development. Single-celled organisms may have been preying on each other for billions of years, with the earliest definitive fossil evidence dating back to about 780 to 740 million years ago. Early animals likely consumed microbes from the outset, and some may have captured larger prey as well. For instance, Aurora lumina, a fossil dated to 560 million years ago, has been interpreted as an ancient, immobile relative of jellyfish. Given that modern jellyfish are typically predators, scientists suggest that Aurora lumina may have snagged passing algae or plankton from the water. However, this passive form of predation is a far cry from the active hunters that would evolve later. The challenges of becoming a predator. The transition from passive nutrient absorption to active predation was not a simple process. It required the development of several crucial adaptations: mobility, the ability to move in search of food; sensory systems, capabilities to detect and track down prey; specialized anatomy, features for capturing and subduing prey; digestive adaptations, the ability to break down and absorb nutrients from other living organisms. Let's explore some of the earliest evidence for these adaptations in the fossil record. Early adaptations. Kimberella and the rise of mobility. One of the earliest creatures to exhibit adaptations crucial for predation was Kimberella, dating back to about 558 million years ago. While not a predator in the conventional sense, Kimberella possessed two critical characteristics that would later prove essential for predatory behavior. Mobility. Kimberella fossils have often been found alongside trace fossils of trails in the sediment, suggesting the ability to move in search of food. A digestive system. Chemical analysis of Kimberella's fossilized remains in 2022 revealed traces most likely resulting from the digestion of microbes or algae. This indicates that Kimberella had adapted its internal organs to actively break down and absorb nutrients from other living things. While Kimberella was more of a grazer than a predator, these adaptations laid the groundwork for future predatory species. Echuria. The evolution of sensory systems. Another crucial fossil in understanding the evolution of predation is Echuria, an animal from around 550 million years ago. Echuria lived and burrowed beneath the microbial mat along the ocean floor. Its fossils, found in the Flinders Ranges of South Australia, typically consist of trace fossils of tiny, meandering tracks about 1 to 3 millimeters wide. What sets Echuria apart from other Ediacaran animals is the purposeful nature of its movements. Unlike the meandering trails of grazers like Kimberella, Echuria's fossil tracks cross into body fossils of other animals, such as Sprigina, and even turn towards them. This suggests that Echuria was actively seeking out other organisms for nutrients. While it's unclear whether Echuria was a true predator or a scavenger, its fossils provide evidence of a developing sensory system capable of detecting and tracking down food sources. This adaptation would prove crucial for future predators. The unnamed predator. Specialization in action. Perhaps the most compelling evidence of active predation in the Ediacaran period comes from an unnamed predator known only by the marks it left behind. Fossils of Cloudina, small worm-like creatures that lived in tube-shaped shells, have been found with peculiar holes drilled into them. These holes, discovered in fossils from central China, provide several key insights into the evolution of predation. Targeted approach. The holes are consistently drilled in roughly the same area of the Cloudina shells, suggesting a deliberate and specialized hunting technique. Species differentiation. Similar species living alongside Cloudina, such as cynotubulites, do not show evidence of these drill holes, indicating that the predator could distinguish between different prey species. Lethal intent. The absence of healing in the Cloudina shells suggests that the drilling was a lethal attack rather than a non-fatal interaction. This evidence points to the existence of a specialized predator with the ability to locate prey, distinguish between species, and target specific weak points. Such behavior is reminiscent of modern mollusks that use their radula to drill into prey. The ecological impact of predation. The emergence of animal-on-animal predation had far-reaching consequences for Ediacaran ecosystems. As predation became more common, it likely triggered an ecological arms race between predators and prey. Evidence of this can be seen in various adaptations. Defensive strategies. The formation of vast Cloudina reefs may have been a strength in numbers, defense against predators. Evasive behaviors. Fossil trails of herbivores show evidence of abrupt changes in direction, possibly indicating attempts to escape predators. New habitats. The rise of predation may have spurred some animals to adopt burrowing lifestyles or to evolve into free-swimming forms to avoid threats. Ecosystem changes. The once vast microbial mats began to disappear as grazing became more common, a process likely accelerated by burrowing animals searching for prey or trying to avoid predators. Anatomical adaptations. Anti-predator defenses, such as hardened inner and outer skeletons and armor, evolved in response to the increasing threat of predation. The Cambrian explosion and the triumph of predation. By the Cambrian period, which followed the Ediacaran, predation had become a major part of animal life. The fossil record from this time shows the appearance of large, unambiguously predatory species like the fearsome Anomalocaris. Some scientists have even suggested that the arms race between predators and prey was a driving factor behind the Cambrian explosion, a period of rapid diversification and evolution of complex animal life. The evolution of predation among animals was not a simple or straightforward process. It required the development of multiple adaptations and likely involved significant risks for the early predators. By giving up other adaptations used to obtain energy, these animals were making a risky evolutionary bet. However, the success of this strategy is evident in the diversity and complexity of predator-prey relationships we see in the modern world. Conclusion: the legacy of early predators. The story of how animals first evolved to become predators is a fascinating chapter in the history of life on Earth. From the peaceful Ediacaran seas to the dynamic ecosystems of the Cambrian, we can trace the development of crucial adaptations that allowed animals to hunt and consume one another. The evolution of predation had profound impacts on the trajectory of animal evolution. It spurred the development of new sensory capabilities, more complex nervous systems, and diverse anatomical adaptations for both predators and prey. The ecological pressures created by predation likely contributed to the explosion of animal diversity and complexity that followed in the Cambrian period. As we continue to study the fossil record and uncover new evidence, our understanding of this pivotal moment in evolutionary history grows. The story of early predation reminds us of the incredible adaptability of life and the complex interplay of factors that drive evolutionary change. From the first tentative forays into active feeding by creatures like Kimberella to the specialized hunting techniques of the Cloudina drilling predator, we can see the gradual assembly of the predatory toolkit that would come to play such a crucial role in animal evolution. These early innovations set the stage for the diverse and complex ecosystems we see today, where the dynamic between predator and prey continues to shape the evolution of species. The rise of predation among animals stands as a testament to the power of evolutionary processes to produce novel and complex behaviors from simple beginnings. It's a reminder that even the most fundamental aspects of animal behavior, which we might take for granted today, have a long and fascinating evolutionary history behind them. As we look back on this ancient world and the creatures that inhabited it, we're left with a sense of wonder at the unlikely series of events and adaptations that led to the rich tapestry of life we see around us today. The story of early predation is just one chapter in the grand narrative of life on Earth, but it's a crucial one that continues to shape our world in countless ways.